Simplify the following radicals. A number expressed entirely as a radical is called an entire radical. As an example, the square root of 20 is an entire radical. In general, a radical is written in the form the nth root of a. The part that is inside the root is called the radicand. The n is called the index. If there is no number shown for n, it is assumed to be 2, which is a square root. If it was a 3, it would be called a cube root. A 4 would be called a fourth root. A number expressed as a rational number multiplied by a radical is called a mixed radical. As an example, 2 times root 5 is called a mixed radical. A radical in simplified form must be expressed as a mixed radical if possible. To do this, we factor out the largest possible perfect square from the radicand, or perfect cube, or power of 4, etc., depending on the index. Recall that prime factorizing can be used to find these factors if necessary. We take the square root of this factor, or cube root, or fourth root, etc., to obtain an integer. The other factor is simply left inside the radical. Our first example, the square root of 56. Note that we can rewrite 56 as 4 times 14, or root 56 as root 4 times root 14. The square root of 4 is exactly 2, and then we will leave the 14 inside the radical, giving us a result of 2 root 14. For root 24, we can break it up to root 4 times root 6. Then the root 4 is 2, so we have 2 root 6. For the square root of 128, we can break that up into root 64 times root 2. The root 64 is 8, so our answer is 8 root 2. Note we might not always find the largest factor that is a perfect square. If we don't, we could still get the correct answer. For instance, if we break up 128 into 16 times 8, this then becomes 4 root 8. We would then notice, however, that the root 8 can further be broken down. This would give us 4 times root 4 times root 2. Then we can change that root 4 into a 2, giving us 2 times 4, or 8 root 2, and thus we can obtain the same answer even though we did it in 2 steps. Now moving on to a cube root. The cube root of 54, we can write that as the cube root of 27 times the cube root of 2. The cube root of 27 is equal to 3. We then have a result 3 times the cube root of 2. The next one is a fourth root. This time we have to look for factors that are powers of 4. 81 is a power of 4, since 3 times 3 times 3 times 3 equals 81. We can then break this up into the fourth root of 81 times the fourth root of 2, giving us a result of 3 times the fourth root of 2. Finally, the fifth root of 96. We break this up into the fifth root of 32 times the fifth root of 3. Note that 32 is in fact a power of 5. 2 raised to the 5 equals 32. We can then rewrite this as 2 times the fifth root of 3 as our final answer.